Hey guys, good morning. Just following up with our where we left off in the notes, in chapter 11 here. So hopefully you were able to go through the beginning part of that the other day or over the weekend or yesterday. So as we talked about, we're doing chi-squared analysis for what we call chi-squared test for goodness of fit. All right. Hopefully we understand by the end of this video how to make sure we state the appropriate hypotheses, make sure we understand how to find the expected counts. We want to calculate that chi-squared statistic. We want to understand the functions in the calculator that might help us do that, as well as identify the p-value that'll ultimately lead to our conclusion for each test. Okay. There's also this last bit here where we want to make sure we understand how to conduct this follow-up analysis, and I'll show you what's meant by that. Okay. In your notes, if you just kind of refer to this example right here, this landline surveys. So it says, according to the 2000 census, all U.S. residents aged 20 or older, it gives a percentage breakdown of those that responded that were in their 20s, 30s, 40s, 50s, or 60 and above. All right. The table below shows the age distribution for the sample of U.S. residents aged 20 or older. Members were chosen by simply dialing landline telephone numbers. And what we're asked to test here, do these data provide convincing evidence that the age distribution of people who answer landline telephone surveys is not the same as the age distribution of all U.S. residents? Okay. So what I did was I set up your HO and your HA, as you'll see in the notes. You do need to be pretty specific for the null hypothesis. So write it out in its entirety. The age distribution of people who answer landline surveys is the same as the age distribution of all U.S. residents. And simply the HA is going to be that it's not the same. So you can abbreviate the HA as long as you completely write out the HO. Okay. And that's just for our purposes, definitely not on the AP test. The AP test, you want to make sure you write out everything. Okay. Now, this part I did not complete on your notes. I had it in mind that we would do this together. So let me just figure out where I have this here. Okay. So I went ahead and I wrote it out for you. You can see that the data we know that comes from a random sample of U.S. residents, they simply just answer telephone surveys. Okay. 10% rule is also satisfied here because obviously the people that were surveyed, the 1,048, is less than 10% of all U.S. residents that are 20 or older. And the thing with the large counts, okay, here they have all expected counts need to be at least 5. So you have to do a little math in this step or prior to it. You're going to have to take each age group, okay, and in the problem it identified the proportion that fell into that group. So 19.1% times the total sampled, we would expect 200.2 people, all right? If there was really 21.5% in this age group, then we would expect 21.5% to answer the telephone survey, all right? So, and 21.5% equates to being 225.3 people, all right? So these are expected counts. Out of our 1,048, we would think these would be the people that would respond in that particular age group, all right? Our expected counts. All those numbers are clearly bigger than 5. The large counts is satisfied. All right. This next part is a little tedious. It's important that you know how to do it. I'm going to show you also. Let me just close this out. All right, I'm going to show you how to not only do it by hand here, but also the better way is on the calculator. So I'll also show you how to do that as well. I was able to get the TI Nspire software, similar to what we use in class, on my screen now. So you'll notice the chi-squared is the observed minus the expected squared divided by the expected. So it is a little time consuming. Take your time with the numbers. You want to make sure you do this part correct, obviously. So you would take each age group, their observed count, minus what we found to be the expected count, and square it, then divide by the expected. So the observed numbers would be given to you in the problem. The 141 20-year-olds, the 186 30-year-olds, the 224 40-year-olds, okay? And then the expected counts that we found using the percentage breakdown would also be included here. The sum of these came to 48.2. And once I got 48.2, I then went to chi-squared CDF, lower bound, upper bound, degrees of freedom. Degrees of freedom is the number of categories minus 1. Well, we have 5 age groups. 5 age groups less 1 gives us a degrees of freedom of 4. All right. And then from that, we know that once we get a p-value, we'll be able to make a conclusion. Okay. So what I'm going to do is I'll give you guys a minute, jump on your calculators, all right, open up a list and spreadsheet, and you can type in what I have here for the observed. Now, you could abbreviate these columns. I wrote them out. You could just probably put O and E, but I put observed and expected so you can see it. And you're going to first list your expected counts. All right. I'm sorry, first list your observed counts, and then what we'll do here is go ahead and put these expected counts in. We said the other day, I know we're dealing with people in this case, but don't round the whole numbers. Keep the decimal. All right, so there's your observed, your expected. You can certainly pause the video if you need to. So let me make sure I did it right, 141. All right, looks like we're good. Next thing we're going to want to do is hit menu. All right, statistics, stat tests, and there's 2 chi-square tests listed. All right, right now we're doing a chi-square test for goodness of fit. The next section we'll talk about these two-way tests, but for now, chi-square test of goodness of fit. So you can hit that. My observed list is in column A, or if I wanted to, I could put however I titled the column. My expected degrees of freedom is 4. I don't have anything in column C, so we can put our results there. And you'll notice, here's our chi-squared statistic. So the same thing we got by hand, you see on the calculator. All right, now, tough to see here because of how we have our settings, but if you scroll over that, well, you might not have to on your calculator, but if I scroll over it, you can see that that's e to the negative 10, which essentially is 0. No need to write out those 9 zeros, guys. So just put is approximately 0. All right. Here's another feature I just want to highlight: comp list. Okay, it stands for component list, and if you scroll over that, each one of those numbers there corresponds to, I guess the right word is the quotients of these values here. So if we did the math for 141 minus 200.2 squared divided by 200.2, we would get about 17.5. Okay, and that's important because these are the numbers that kind of lead to our follow-up analysis, if you will. All right. Let me pause this real quick and go flashback. All right. Referring back to the notes. So you'll see in your notes that here's our answer. We basically got something that's 0, which is less than 0.05, which leads us to convincing evidence that the age distribution is not the same as the age distribution of all residents. All right. The breakdown of people that actually answer landline telephone surveys, is different. Now here's our follow-up analysis. So here's all the information that we just found listed in a chart. Okay. And what we could be asked here is we could be asked something like, well, what component, contributed to us rejecting the null hypothesis the most? And in this case, just look to see what the biggest difference is between the observed and the expected. All right. So the 2 age groups that contributed the most would be the 2 largest differences, right? Would be those in the 20s and those in their 50s. Okay, why? Because, well, they had the biggest difference between what actually occurred and what we had expected to occur based on our percentages, right? These numbers here that you'll see listed in your notes are the same numbers that the TI Inspire found for us. All right. So what I'd like you to do, guys, this concludes our first section of notes. So hopefully you watch this video. It's supposed to be nice today. Hopefully you guys get outside, enjoy the weather, after yesterday. of course, social distancing, but get outside, try to enjoy it a little bit, take a walk, ride a bike, something. I'm also going to post, or no, you have it. So I asked you guys to make sure to like print out, or if you just wanted to save as a PDF, up to you. But you should have all the quiz worksheets throughout the chapter. Do the first section's quiz. So do 11.1's quiz. Try to get it done by 2:00 today. And then later on tonight, what I'll do is I'll post an answer key. All right, I'll post my answer key to be available for you guys. All right. So hope all is well. Enjoy the day, guys. Talk to you soon.